Alright, on this last part here, we got two quick examples of one. This first one here, we're still given some congruent segments, and this is very typical. They'll say you have some congruent segments, prove that some other ones are congruent. And so one thing I want you all to do is, before you just start writing these proofs, I want you to really think about, what is it asking me to do? And what is it giving me? Is it really all making sense before I try to prove something? Because if you don't really understand what they want you to prove or what they've given you, it's going to be really difficult to follow through with that. So looking at this one, they told us at the beginning that HI and TU are congruent. So I'm going to go ahead and just mark up my picture. Go ahead and do that for yourself so you can have those visual cues, which things are going to be the same length. The next thing they tell us is that HJ, or this entire segment, is congruent to this entire segment. Okay, so these parts are congruent, and then this whole thing is congruent to this whole thing. And they want us to prove that this remaining length has to be the same as this remaining length. So essentially they're saying if these two whole parts are congruent, and you take off congruent parts, you should be left with congruent parts. So in a way, it's kind of like proving a segment subtraction. Now, we don't have a segment subtraction postulate, but this is asking us to kind of prove something like that. So we're going to start the same as we always do. Always copy down that given statement or set of statements. And we need to be able to work with equations when we're going to be subtracting, adding, whatever. So go ahead and just switch to equals by definition of congruence. Now, just like with pretty much every segment proof we do, we need to use that segment addition postulate somewhere. We want to talk about what is HJ made up of and what is TV made up of. Made up of two different parts, each of them. So I'm going to say HJ is the same as HI and IJ, and TV is the same as TU added to UV. That segment addition postulate. Alright, so we know that the left sides of this thing are equal because they told us so, and it's right here, or right there actually. So if the left sides are equal, then the right sides have to be. That is that transitive property. HI plus IJ is the same as TU plus UV. And one thing we already have here is HI and TU are the same. So HI and TU. So since those are equal, I can subtract that same amount on both sides. So I'm going to subtract from the left and from the right the same value, HI and TU. By subtraction, I get IJ equals UV. And I mean, if you want to go ahead and substitute one of them in, that's totally fine. Like if you want to take out HI and put TU, then you can see that they're equal. You can add an extra step. There's really nothing wrong with that. Some people prefer it, but I think you all are kind of advanced enough just to see that they're the same, and so I can subtract the same amount. And then the last step here is we want to prove congruence. We don't want to prove equality. So if we have equal length, then we can say we have congruent segments by definition of congruence. Okay, so that wraps that one up. The last one, this is the last one we're going to see today. It's kind of tricky because there's no picture. Anytime this happens in our class, you want to draw yourself a picture. So first thing, A is midpoint of MD. I'm going to draw myself just a segment, MD, and I'm going to put A in the middle, and I know that those are congruent. And then tell me R is the midpoint of AD. So if I go to this segment AD I just drew, I'm going to put R right in the middle, and put some tick marks right there. They want me to prove that DR, this right here, is a quarter of the entire thing. Right. So, in other words, you could say, given all of that, prove the statement right there. So I'm going to just put a is midpoint of MD. R is midpoint of AD. And that is by the given information. Okay. Now looking at this thing, I can break this apart all kinds of different ways. I'm gonna, you can look at MA plus AR plus RD, a lot of different combinations. Now, I'm going to use this definition of midpoint first, though, because I know that by definition of midpoint, MA is the same as AD. Also, AR is the same as RD. I'm going to say DR, because they want me to say that at the end. DR. This is by the definition of a midpoint. Okay, so let's see here. I'm going to go ahead and look at the segment addition postulate. Let's see here. Say DR plus AR plus MA equals MD. It's by my segment addition postulate. Alright, now I can swap in some things if I want to, but I might need to do a little bit of preliminary work here. So AR and DR are the same. Okay, so I can replace this with 2DR plus MA equals MD. It's by substitution. And I know that AD and AM are equal by definition of midpoint. So where did I put this here? I guess I should add a step. I could say DR plus AR equals AD. Another segment addition. And really what I need to get at is I almost have it, because if I had a 4DR and if that was gone, I could just use the division property and I'd be done. I don't quite have it, but I'm close. So DR plus AR is AD by segment addition. In other words, 2DR equals AD by substitution, because we know that AR and DR are equal. Okay. So now what I can do is MA, that's the same as AD. Right, so MA here, same as AD. And AD is the same as 2DR. So those things are all equal. I can replace in this equation right here, this one that I almost have it, I can keep that one, so 2DR plus another, instead of MA, I can put 2DR equals MD. It's by substitution. And then I can add those together and replace with equal value of 4DR. Substitution. And then I can use my division property. Divide both sides by 4. So kind of a tricky one. A lot of clever substitution we had to make there.